Hi, I'm Emma, the Commercial Business Manager for Nvidia at Exertis Enterprise, and today I'm joined by Gadi, who's Nvidia Networking. Can you tell us a little bit more about what you do?
Thank you, Emma. So Gadi Godanian, I'm based here in London, and I've been working for Nvidia, joined through the Mellanox acquisition for a total of 10 years. My responsibilities are the networking product across EMEA, and I'm the segment leader for AI networking.
Thank you, Gadi. So we, as Exertis Enterprise, have been distributing Nvidia Networking since 2010 in the days of Mellanox, and we were their first UK distributor. We distribute all across EMEA, and we've got particular focuses in our UK and European offices. So we're here today to talk about Nvidia Networking. Can you give us a brief history of Nvidia Networking and the connection to Mellanox, please?
So let's start with Mellanox. Mellanox have started as a hardware company, manufacturing our own ASIC, building switch systems, focusing on high performance computing. And from then we evolved into other areas, and today we are a full-blown end-to-end data center company when it comes to our LinkX, which is the cables and transceivers, our networking interface cards and TPUs, and then the switch platform and the software on top of that. So this is something that Nvidia, in their journey to be a big AI player when it comes to the data center, this was something that Nvidia could incorporate into their portfolio. So nowadays, when we're combined together, it gives us much more power in terms of how to design the best high performance computing, large language model clusters in the world, by not relying on other companies, but just relying on ourselves in order to build those platforms. So I think this is one of the reasons that big reasons that Nvidia have acquired Mellanox. At the beginning, like around 3 years ago, maybe it wasn't that clear for everyone because the data center part of Nvidia was still small. But now, in retrospect, everybody understands that was a great move from our CEO, and it made a lot of sense. And another way that I like to look at this is Nvidia always had this amazing supercar. But you can't just take the supercar and drive it on the road in your city, because then you won't use the full potential of that supercar. So Mellanox is that racetrack, specialized racetrack that let your supercar takes the performance to the maximum potential. And I think this is why it was a great fit. And now we can definitely see it from revenue, from exposure, and from the amount of cutting edge technologies that are being deployed around the world with a combination of the Nvidia and Nvidia networking product portfolios.
That's a great analogy. So people often think when it comes to networking just about the switching, but you guys have the true end-to-end connectivity, as you said. You've got the networking cards, cabling and transceivers. So where does Nvidia networking play in the market, and what separates it from the competition?
So I think we have several separation points that puts us in a very good, unique position in the market. The first one that I mentioned briefly was the fact that we manufacture our equipment end to end. So this is not necessarily something that is very common in the industry. So let's take a switch vendor, for example. They might buy their silicon, their ASIC from one vendor, and then they will build their system on top of that and put their software. We control the entire end-to-end manufacturing process of that device, whether it's an InfiniBand switch or an Ethernet switch. We build our ASIC, we build the system around it, and then we choose the right software to run on top of that to give it the maximum performance and to tune it to the right use case of the customer. Now, it sounds small, but that can be a very, very impactful thing for our customers and partners. Because we control everything, we don't need to rely on other vendors to decide what features, what product, what focus the product is going to have, right? We control our own fate, we control our own design. So there are a lot of benefits, from feature requests to bug fixes to the fact that we control the production line. So we have our the ability to decide which platform we're prioritizing when it comes to challenging days like days with the problems of supply chain that we've been having in the past few years. So having our own ASIC is definitely one of the main benefits of our networking equipment. The second thing that you explained very nicely is the fact that we have this end-to-end notion in the data center. We have our transceivers, our NICs, our switches, the software on top of that, and this is truly an end-to-end play, an end-to-end capability that we drive. So the same software can monitor all of those equipment types together. The backward compatibility of the LinkX or NICs. They can use InfiniBand or Ethernet. The fact that we have all of this together gives our customers a lot of flexibility in terms of how they deploy and what they want to do with the equipment. And I would say the third thing is Mellanox was relatively a small company compared to the other giant when it comes to networking in the world. So we had to be laser focused on what we're doing. And I think this is one of our superpowers actually, because we couldn't take every use case around there and storm it and be very successful in it. So we chose very carefully the use cases and the areas and verticals that we want to focus and we want to dominate. And this is what we're doing. And this is also part of the reasons that it was a very good, appealing company to be acquired by Nvidia. So those areas were always HPC, which is very similar to different AI workloads. So now it's also an AI data center and cloud, where now all of those things are evolving, where we are in the past few years focusing on how we can take just any cloud and make it an AI cloud. And this is something that we are working hard, and we'll probably discussing more about it in this podcast.
We will. So as you mentioned, the end-to-end portfolio from Nvidia is unique in the market, and you guys have been the leader in 25 gig NIC space for some time. And the rich features of the card and the performance and the efficiency. Can you help us with the overview of the latest Connect X7 family, please?
Yeah, so when it comes to 25 gig NICs and above, so anything with a higher bandwidth, we definitely control this market, and this is something that we've investing, many years in trying to build this leadership. So 25 is great, but we can take it up to 400, and each and every customer can pick and choose what's the right solution for them depending on the use case that they're running. So to your questions about Connect X7, this is our latest network interface card, which is also the building blocks for the Bluefield 3 DPU that we'll discuss later on. And Connect X7 can run in Ethernet or InfiniBand mode with many different type of connectivity, 1 port, 2 ports. Everything is backward compatible, so you can run lower speeds if you want, but the card itself can go up to 400. And the unique part about the Connect X7 or any other Connect X family card is not just the bandwidth and the latency, but what can this card do for you extra than just sitting there and passing traffic. So, and this is where the bridge between just a normal NIC to a smart NIC to a DPU is blurred. So I would say on top of those things, anything that we can do with the security offloads, storage offloads, or networking offloads that we can use some examples later on when we'll discuss the DPUs, these are the main characteristics that the Connect X7 card is very useful in.
Okay, thank you. So your Ethernet switch brand is called Spectrum. Can you tell me some more about the Spectrum in the changes in the Spectrum lineup, please?
Yeah, so the Spectrum product portfolio is very dear to me. I've been working on that portfolio for many, many years, from QA to support to sales roles in the field. So it starts with the 32 ports of 100, which is the Spectrum One the type devices, and we have several of those. And then the portfolio enriches and grows up to 400 and 800 with the latest Spectrum 4. So we won't go through the details, everything can be found online, but the idea is that basically everything you need from networking design portfolio, from networking design is there in the portfolio. Again, we laser focus on data center and HPC, anything that is high-end networking cards. So we don't do campus, we don't do routers. We only do those specific areas with data center networking. With Spectrum 4, which is the latest 51.2 tera, meaning that you can have in one ASIC up to 64 ports of 800 gig. It was a massive success from our side. We're very excited to go to market with this switch, and there are a lot of amazing potentials, especially when it comes to AI and other very demanding workloads.
So recently you made some Spectrum switches end of life, including popular products like the 2410, the 2700 100 gig switches. Can you go into why?
So every good story has its own end, and this is the end of 2410 and 2700. These were indeed high runners, and they were very successful products. They've been out there for about 8 years, and like any other product, they are built out of other components that some of them we make, some of them we acquired, like CPU. In that case, the CPU time have come and it's begun its end of life process, and we want to ensure that our customers get the best solutions and products from our side, and we decided that this is the right time to start the end of life and end of this process. All of the information is online. We're still in the middle of this process, and for specific use cases, we'll support our customers. So feel free to reach out for us if you have anything that you need on those platforms. For the 2700, we have a replacement, which is the 3700. That can do everything that the 2700 can do, just with the newer silicon with Spectrum 2 based ASIC. And for the 2410, we have the 3420, which is exactly the same, just better. And the Spectrum 1 ASIC is actually not going anywhere. It's just those two platforms. We have other products in that range. We've even introduced about a year ago a new product line to the Spectrum 1, which is a management switch. There's a lot to come for the Spectrum brand.
So DPU, data processing units, it's become a real buzzword in the industry. Can you tell me more about your solution, the Bluefield card, where it fits, who needs it, and what is the Bluefield 3 DPU?
So the Bluefield 3 DPU is actually a Connectix 7 with ARM cores on it and some extra memory and security enhancements that are physically on the card. And the idea behind it is that the ARM cores is giving you almost like a small server in front of your main server that you plug in. So now you can log into the Connectix, to the DPU card and manage it and install different agents on it without the main server noticing it. So the idea is you manage those DPUs in front of your server, and you use the Connectix 7 to offload any tasks that you don't want the main server to be involved with. So the main server just focus on their money-making processes that are there for the business, and the cards themselves, the DPUs, are taking some of the jobs like security workloads, storage workloads, networking workloads, and offloading it from the main server. That's the magic of the DPU, a combination of what can we offload to hardware with Connectix 7, and how can we manage it, how can we monitor it, how can we add security layers on top of the ARM cores. Just to give an example, if you want to run this aggregated firewall and you don't want to install the agent on the main server and deal with patching and management, you can just do everything on the DPU. And this is what we see in the ecosystem, that we see more and more examples of different security vendors building an ARM-based agent that runs on the DPU and protect the server without the server even knowing about it. And there are many other use cases like IPsec or TLS that we can run on the cards, different type of storage enhancements like NVMe over Fabric, or even running routing on the server itself by doing so, reducing the amount of human errors in the network, getting rid of layer 2. So there are many different benefits of using Bluefield instead of Connectix. It just really depends what is your use case. You can also find Bluefield 3 as part of many different reference architectures that we are building and we are promoting to our customers and partners, because this is part of our ecosystem that we're building. And it will have different type of building blocks already embedded into those. And when we test and verify those architecture, we're using Bluefield 3 to get the maximum benefits.
Great. So you mentioned ARM. How does that differ from x86, and what software would be needed?
So let's start with the software bit. I think Nvidia was very good at taking the Bluefield DPU and making sure that it's no longer a buzzword. With Nvidia, we've built the Docker libraries, which contains different type of software and containers that we can run on the Bluefield DPU. Some of them are closed and built by Nvidia or our ecosystem, and other ones are open source that the ecosystem can actually come and develop and build on top of that. And this layer actually gives you this wonderful amount of different use cases that you can run on the Bluefield as part of our Docker environment, just like we have with CUDA for GPUs. So this is how the software enables Bluefield to have more and more use cases. When it comes to ARM cores, we see ARM storming more and more parts of the world, just because it's a lightweight way of running compute. The hardware footprint is much smaller. You need much less power, and it makes a lot of sense when you're running when you're trying to add more computing power to the server. You need to be very mindful of the real estate and the hardware space that you're consuming. So this is why ARM cores are a very good fit. And if we'll take it to the extreme, in some of our reference architecture that we build, you can find up to 9 Bluefields in one server. So you need to keep in mind that you want to get the maximum performance, but at the same time, you need to build something that is manageable, something that the server vendors can actually support. So ARM is a perfect fit.
Oh, great. So let's skip on to AI. It's everywhere now, and ChatGPT has become a household name. With Nvidia being a major player in that space, can you tell me or help me understand the challenges that brings to networking?
So that's what we've been focusing on since the acquisition of Nvidia. How can we, like I said earlier, how can we take a cloud and make it an AI cloud, right? What can we bring to the table to cater for the growing demand of AI? Especially recently, like you said, with the ChatGPT, with the large language models. So, there are a lot of challenges that AI brings to the table. Some of them are more easily, we can more easily solve through one protocol or technology or the other, which we'll talk about later. But let's try and stay and focus on the challenges right now. So, traditional data centers usually will have a lot of different flows, which are relatively small flows, and you can move them around. They're not tightly coupled to specific ports or links, and the entire idea behind the data center is that we can work with failovers and we'll let it be as dynamic as possible with our underlying technologies that we are running. For AI, especially talking about large workloads that requires multi GPUs to communicate between each other, this will not work. And if we go a bit deeper, ECMP, which is equal cost multipathing, which is the dominant hashing-based protocol to distribute traffic across leaf and spine technologies, will not work. Because with AI, different type of AI workloads, the same fundamental thing happen is that we want and we need to squeeze as much bandwidth as possible, talking about 400 gig on a 400 gig NIC, and we need to make sure that this is lossless without any traffic loss, which again, this is something that traditional Ethernet networks cannot do by themselves. So we need to come and think about ways to solving that. So we need to find a way that each and every AI flow that runs through the traffic will have its own dedicated links, that nobody else is interfering with that link. It's a big challenge for AI, and this is just one of the big ones. And we have different ways of solving that, which we'll probably discuss later on.
Okay, so the connectivity of choice for HPC and AI traditionally has been your quantum range InfiniBand. Why is your focus on Ethernet so strong?
So I think the focus on Ethernet is so strong because InfiniBand is already dominant and it's doing well. So we keep investing in InfiniBand, we keep investing on quantum series, but we've been doing it for so long. It's such an amazing solution for AI that we want to expand, and we want to offer our customers and clients of a choice. We want to offer them more options, right? They can go with InfiniBand if they want. We have a reference architecture. Everything is tested. Everything is certified. Everything is predictable when it comes to performance. And we want to expand that so our customers can choose the right technology for them. It can be for them because of the company DNA. They want to stay on protocols and technology they understand, that they have the knowledge base inside the company, or it can be the right choice for a specific customer because of their business model. Maybe a CSP would like to stay with the Ethernet because of the ecosystem that they've already built around it. So again, the idea is InfiniBand is doing amazingly. Ethernet needs more help, and this is any Ethernet out there. And there's a lot of efforts across the industry to tune Ethernet more and more for AI. I just think that we have a bit of a heads up because of the fact that we got acquired by Nvidia.
So you mentioned different types of networks. You touched on it briefly before. How should we consider network design when looking at an AI use case?
So we can talk about this specific question for, 2.5 hours and have a whiteboard design session, and we'll need people that are much smarter than me. We actually started doing more webinars and hands-on face-to-face sessions where we cover and we whiteboard and we teach our client and customers how to design networks for AI. So this is actually a very interesting question. Oversimplifying it, what we need to understand that for every large multi-GPU workload out there, there are two types of networks that are needed. One of them is the GPU to GPU connectivity. You need to think of it as an island in your data center, which is a separated network. We call it in our reference architecture east-west, meaning that the GPU to GPU will communicate between themselves without any connection to the outside world. And this network will have the most challenges, like we described in the previous questions, where you need to have a very, very dedicated network that is tuned for performance and performance only. And this type of network will have dedicated technologies running on top of that. You cannot just run any Ethernet. You need to run, in our example, Spectrum X, or to run over there InfiniBand. And for north-south connectivity, meaning anything connected to the storage, to the outside world, to the management or scheduler, all of those layers that help run this multi-GPU fabric are sitting in the north-south, because for every GPU to GPU that communicate between each other, somebody needs to log in, somebody needs to configure it, somebody needs to manage it and allocate different times. So all of those management components are located in the north-south network. Now, the north-south network is not necessarily performant. It is important to build it right, exactly like we say in our reference architecture. But the focus is not necessarily performance. Over there, you need to have something that you can deploy easily and it can scale. Automation is key, and also interacting with our third-party ecosystem that can run on the Bluefield cards and give you the added security, added flexibility when it comes to networking, like networking on the host, layer 3 on the host, like I've said earlier. So these are two very different networks: east-west, performant, GPU to GPU connectivity, and north-south, resiliency, manageability, and connecting to anything else other than the GPU to GPU itself.
You mentioned Spectrum X. It's been released to solve the Ethernet network AI challenges. Can you tell us about what makes up the Spectrum X solution?
So Spectrum X is an end-to-end solution that combine Spectrum 4, which is our 51.2 terabit latest switch into the market, SN5600, 64 ports of 800 gig, and Bluefield 3, with the software bit running on top of that. And the magic behind Spectrum X is how can we take all of those challenges that we described with AI networking and solve them with an Ethernet-based solution that can also be used for cloud, for example, right? Where those are the same components, those are the same building blocks. And the way we do it is, from technology perspective, we will use adaptive routing and enhanced congestion control to understand what's going on within the network, within the leaf spine network, and then fine-tune the routes that traffic takes in order to make sure that each and every GPU flow will get the maximum performance, the maximum bandwidth, without leading to any performance degradation on other links. So this is the main challenge, and Spectrum X comes to address this main challenge. There are many other benefits that Spectrum X bring to the table, but this is the main challenge that it comes to solve. And to oversimplify things, the way I look at it is almost like the switches breaks the network because they change the routes that the different flows get, and then the Bluefield at the other end fix everything that happened in the network in order to make the GPUs unaware of those changes. So in any east-west network, you will need to have Spectrum 4 and Bluefield 3, and the magic happens between those two. This is why we're very well positioned to solve this problem compared to other vendors in the industry, because we have those two components running together as part of this entire solution. But I think what's most important when it comes to the Spectrum X solution is not just necessarily the technology. The technology is important, right? This is where we innovate. But the idea that our customers and partners need to understand that we're Nvidia now, and this is what we've been doing for the past 3 years, and this is what we're going to do more and more with our Ethernet technologies as well. We have an army of talented engineers who build those technologies like nickel that we haven't touched. We can get we can explain more about it offline. You can look it up, but this is basically the protocol that GPU to GPU use for communication. We've built that. We have those engineers within our people and their skill set that we have within Nvidia and Nvidia Networking. We have massive investments in building our own Ethernet-based supercomputers like Israel 1, which will be built upon 2,000 H100 GPUs with Dell through an HEX solution, with 2,500 GPUs with 100 Spectrum 4s. So we're putting the money where our mouth is, and we're not just building a technology, but we're also making sure that we can scale that technology. We give you a reference architected, tested and validated solution that you can just copy what we're doing. Our professional services are building that to other customers, to us in Nvidia, so they're ready to turn you a turnkey solution that we've been deploying and doing elsewhere. And the beautiful part about it is if you follow this reference architecture, you know exactly what you're gonna get from performance perspective. So I would say Spectrum X is not only just the technology itself, it's also the investment that we've put behind it in order to fine-tune it to the best type of performance to cater different type of use cases, AI use cases. And that's Spectrum X in my eyes. And Spectrum X is also evolving, and you need to stay tuned for our upcoming announcements from our CEO in the upcoming summits, because we're adding more and more capabilities and more we're enriching the Spectrum X ecosystem.
Great, thank you. So where should people go to get more detailed information on Spectrum X?
So first of all, everything is online. Everything can be found on our website and on our dedicated links. Also, I encourage you to work with your Exertis team, work with the local Nvidia members, and we'll be able to give you all the latest information about SpectrumX or anything else that you require. We have been working closely with the Exertis team to enable you on ConnectX, Spectrum, and our DPUs. What is the best way to work with Exertis on Nvidia Networking?
So you touched on it. We've got a great relationship with historically Mellanox and now Nvidia, and we've got a team of people aligned specifically to Nvidia: commercial, pre-sales, business development. Everyone will have a direct point of contact with their account manager within Exertis Enterprise. So that's the first port of call, and then we'll set up another call with Nvidia and maybe a workshop as well to go into some more detail in depth.
Exertis are a key partner working with Nvidia and Mellanox over the past 12 years. What trends do you currently see with Nvidia Networking and the explosion of generative AI in the market?
So we've seen a significant ramp up in our networking business around AI in the past few years. And it's been around the InfiniBand solution, it's been the first movers and dedicated AI players. But now with the spark of ChatGPT and the iPhone moment for AI, as it's been called, it's led to an explosion in demand. Now we see that's coming from the Ethernet side as well and the mainstream market. So with our key vendors, they're consistently focusing their networking and AI strategy with Exertis Enterprise, and we expect generative AI to be a considerable part of end users' budgets in 2024.
Sounds exciting.
It is. It's very exciting. Thank you so much for joining us today.
Thank you for having me here.
It's been amazing, and you've really helped everyone understand this amazing part of the technology and the way that things are going in the future. So thank you.
Glad to be here. Thank you for having me.